guys, it's Mr. Hanson 414. We're back. Today we're going to continue what we were working on with 1.1 segment length and midpoints for geometry. So hopefully you already watched part 1. If you didn't, make sure you do that now. You should have a good understanding of the basics. So now we're going to go into distance formula and talk about what that looks like. So you guys should know what Pythagorean theorem is. This is like the one thing that people that will always say they remember about math class. Now, what they'll say is a squared plus b squared equals c squared with no context. They just might know it means with triangles, but Pythagorean theorem is very specific. You need to know that you're only working with a right triangle. That's a triangle that has an angle of 90 degrees. So a triangle like that has 2 legs and 1 hypotenuse. And you can see in this little diagram down here that you can see the right angle is marked. Now you have the hypotenuse, which is the long side. That leg is longer than the short legs on the side. That's why it's got a special name. It's the hypotenuse, and that is always opposite the right angle. So when you talk about a squared plus b squared equals c squared, what you're saying is the sum of the 2 legs squared is equal to the hypotenuse squared, the length of the hypotenuse squared. So there's always lengths here. Now length, you can't have a negative length. You can't be negative 6 feet tall unless you're dead, but you're still not losing height, right? So we are going to talk about the distance formula so we can find the distance between points on a coordinate plane. So this is really just algebraic way of finding something we might need for geometry. So the distance formula is as such. This is something that you're going to want to pause right now. I would just put this whole diagram into your notebook, honestly. It is the distance between 2 points. Now we always label our points x1, y1, x2, y2. If you've done slope stuff, it's just like slope formula. So you are going to use this formula, which is the square root of all of it. So you take the square root at the very end, x2 minus x1, so the second x point minus the first x point. You do that math, and then you square it, plus the same thing for the y coordinates. So you have your 2 points, then you can do this. That's all you need is 2 points on a plane. Got it? Pause. Do what you gotta do. Now you have a whole bunch of things here. Now they give you one full example. I don't really like jumping into their work, so I'm just gonna do my own. But I am gonna follow their kind of setup. So I will follow their setup, but again, you don't need to do all this. You can do your own thing. So you have all these different line segments, right? You have AB or BA. Line segment CD or DC, line segment HG or GH. We have 4 line segments that you can use, and you can find the midpoint, or sorry, the distance between them using any line segment you pick. Just make sure they're on the same line. Now, all of these are, notice, kind of diagonal, so you can't just count the squares. You can't just count the, I'm blanking, but you know what I mean. So here we go. They want us to use line segment EF and GH. So let's find those real quick. So we have EF, right? And GH. Whoa, that curved way more than I wanted to. It is what it is. EF and GH. So if we review what they did for A, B, and CD, they wrote the coordinates, which is good. I personally always label mine, so I would have wrote x1, x2, y2, y1, y2 for each one. They find the length of AB, line segment. They find the length of line segment CD. So they're doing 2 in 1. Don't get confused. They're finding one length, and then they're finding another length. All right? Again, pause if you start getting confused. So what they want to do is they're comparing, right? They're trying to see if these 2 line segments have the same length. You could measure it technically, but this is going to give you a very specific way of knowing if you have the same length or not. So let's do this. What do you think right now just by looking at it? EF, GH? So let's write the segment. So we need to know the coordinates for our points. So we know E is at -3, 2. Remember, it's x, y, right? F is going to be, I gotta put my pen down, so F is going to be at -2 in the x, because I went from the origin 0, 0, 2 to my left, and then down 3, so that's -3, so it's going to be -2, -3, and then I need to get the coordinates for H, so I know where G is, so let's find H. H is right there on the x-axis, so it's going to be 1, 2, 2 for x, 0 for the y. 2 comma 0 is where that one, whoa, it's glitching. All right, 2 comma 0, 2, 0. Now, we know that we have what we need. We just needed 2 points that are on the same plane in order for us to apply the distance formula. So make sure you know what the distance formula is. I literally would write it over and over and over till it sticks. So distance formula is here. We know that we're going to take x2 minus x1, y2 minus y1. So what's x2? Well, I'm going to label my points. So for EF, if this is x1, y1, then that means this is x2 and y2. So E is my first point, F is my second point. If you do it the other way around, it's fine too. So we're going to plug in x2, which is negative 2, substitute it in. And we're going to plug in y2, which is 2. Nope, sorry, that's not. Y1 is 2. It's negative 3. Now, how do I erase? There it is. Pen's a little touchy. So, my bad. And I'm glitching just a little bit right now. So I'm going to pause for a second. Okay, I'm back. I got the eraser to work. So, again, I almost made a mistake. So, y2 goes first. So that's negative 3. We're all substituted in. So now it's just time to do some math. Negative 2 minus a negative 3. So if you remember how positive and negatives work, when you subtract a negative, you're just really adding the opposite. So it's going to be negative 2 plus a positive 3 instead of subtracting a negative 3. Negative 2, positive 3. If you have 2 bad guys, 3 good guys, they get in a fight, they take each other out, you're going to have 1 good guy left. That's 1 positive. On the other one, you got negative 3 minus 2. Now, that's not anything tricky. You're just spending $3, and then you're spending $2 more. You're going to be broke. So when you spend $5, that's negative 5. Now, they don't really give you room to, like, do every step, but I'm going to do every step because I don't want you guys to get lost. When you square something, you're multiplying it by itself. So 1 times 1 is 1. Now, negative 5 times negative 5, a negative times a negative is always a positive. You got to be careful, though, because when you start putting exponents in or without parentheses, you can make mistakes. So negative 5 times negative 5 is positive 25. And then we add those together and we get the square root of 26, which you could put in your calculator. We don't need to right now, but we know that's going to be a little bigger than 5, so I'll say it's like 5.1. I don't know, approximate. That's why it's got those wavy. My equal signs are wavy. So pause. Do the same thing for GH. I'm going to let you do that. Okay, so you can look and see that for GH, I went ahead and labeled x1, y1, x2, y2, get myself nice and set up and preparing for success. Then I substitute in x2 and y2, 2 and 0. And now I'm ready to do some math. Now I got 2 minus a negative 2. So what do you do when you subtract a negative? You add the opposite. So plus a positive 2, which is 4. 0 minus a negative 4. Subtract a negative, you add the opposite. Getting that repetition here on our positive negative. 0 plus 4 is 4. 4 makes perfect squares. 4 times 4 is 16 plus 16. And then we would take the square root of that, which is 32. But I don't even got to do the math, even though I know that's probably somewhere like 5.6. It's not quite 6, but it's bigger than 5.1. The question was, are these the same length? Obviously, the square root of 26 is not the same as the square root of 32, even if you don't know how to put that in your calculator. So, therefore, those are not equal length. So this is something that I think would be a good challenge for you guys to work on your own. We can talk about it in class, but the Pythagorean theorem and distance formula are related, so do some research if you get stuck. A little bit of practice on your own. So I'll get this set up for you, but I want you to pause it first and try, but I'll go through the setup. So for me, I like to figure out my points. So I would write out my points, then I would go ahead and label them, right? Get the x1 and the y1. So J would be my x1, y1 for the first line segment. K would be my x2, y2. And you're just plugging in, you're making sure that you get it right. So I'll give you guys the answer. So pause it, do the work first. So after you do everything, you should get that both of them are equal in length because they are both the square root of 13. So if you did it right, you should have found out they were the same length for both line segments at the square root of 13 is their length, which would be somewhere between 3 and 4. I think that's closer to 4, so like 3.6 maybe. Approximately. So So to find a midpoint, you're just looking for the point on the line segment that divides that one segment into two of equal length. So you can look at this diagram, you'll notice that M is considered the midpoint because it breaks that line segment perfectly in half. These little tick marks show that the line segment PM is equivalent in length to the line segment MQ. And we call that a line, ray, or other figure that passed through the midpoint, the segment bisector. We'll talk more about bisectors as we continue to talk about angles and stuff later. So make sure that you are getting this in. Now we're going to talk about some paper folding. Not going to do that right now. Now you're going to try to fold and talk through it. But if you want to go for it, go for it. It just kind of helps visualize. But you're just talking about bisectors, segment bisectors. So on and on and on. And lastly, finding midpoints on the coordinate plane. So we were finding distances in the first part of this. Then we learned what a midpoint was. A midpoint is the midpoint between two lines. So assuming my hands and fingers are the same point, if I drew a line right here, it would break it in half, right? Then we're going to be able to find these midpoints using the midpoint formula. So I would pause the video right now and copy this down. Okay, so looking at what you got in front of you, the midpoint formula clearly shows you that it allows you to find the point that breaks a line segment in two equal lengths. So we have the line segment AB, and we're trying to find the midpoint. So we use this formula, and it's always going to give you a point. Now that is the very big distinction, right? Distance is going to give you a length. Midpoint formula is going to give you a set of coordinates, a point. Make sure that you get a point when you're doing midpoint formula because you're looking for the point in the middle. So it's annotated by M, which represents the midpoint, and you're taking the x coordinates and adding them together, dividing by 2, and doing the same thing for the y coordinates, adding them together, and dividing by 2. That gives you your new x and your y to get the point. So if we look at what they did for PQ line segment, we've got the points, and they just plug and play, right? They take the x's, so again, you could x1, y1, x2, y2. They plug them in, and they do -4 plus 2, which is -2, and divide by 2 to get -1. And they do the same thing with 1 plus a -3, and they get a -2 divided by 2, which is a -1. So that tells you that the midpoint is at that point, -1, -1. So please pause real quick and try this next one on your own. Same deal. So I'm going to label x1, y1, x2, y2. 3 got plugged in. That is my x2. Oh, let me put this pen down real quick. That's x1 plus x2. I always want to go x2 first. So x1, x2 is -3. For the 5, that's my y1. y2 is -1. Do the math. What's 3 plus a -3? They're opposites. They cancel out. That's 0. So 0 divided by anything is 0. If I have no money, I can't split it between two people because we're all going to get $0. 5 plus -1 is 4. Divide that by 2, you get 2. So that is my midpoint for that one. So since that's all we're doing, it's pretty simple. So I'm going to scroll down. There's some practice problems that you guys can do. So this will be a good time to pause it. Do the math. There's some elaboration, reflecting questions, so think about those. Distance formula is not needed to find horizontal vertical. Think about it. When do you use the distance formula? That's important. We got to know when we need the tools that we have. When you use the midpoint, doesn't matter which point you take. And then there's some practice. So I will just scroll through this in case you want to take a look, but I did drop what you need to do in Google Classroom. Remember, the goal is to just make sure you have an understanding of these things. Now I'm going to go back because there's one thing we didn't talk about yet, which was the essential question. So make sure that you remember what that was. But we basically talked about basic naming conventions for lines, rays, line segments, planes. We talked about what the distance formula is, how it connects to the Pythagorean theorem, what a midpoint is, and how to find it using the midpoint formula. So lots of practice for you guys. Remember, if you need to watch this video more than once, that's totally fine. That's probably recommended because I just did this video in 15 minutes. If we were doing this in class, this probably would have taken probably closer to 30. and I would have been stopping more often and probably doing more examples and asking questions. So this is not the same. So be okay watching it more than once, asking questions. Now, the essential question was, how do you draw a segment and measure its length? I want you to pause real quick and think about it before I give you a answer that I think works for that. Essential questions really just help you understand where you are, right? So how do you draw a segment and measure its length? Well, you could always like draw a picture, right, with a straight edge and the compass, which kind of talks in here, but we skipped over it. Otherwise, you connect 2 points on a plane, right? Like you make a line segment by connecting 2 points, and then you use the distance formula to find the length. You wouldn't use midpoint formula because midpoint gives you points. So that's it. That's lesson 1.1. Do your practice. Bring questions to me. If you have specific practice problems that you want me to go over, I can always make a video doing that. So, Mr. Hansen, 414, I'm out.